Imagine walking through a sun-dappled forest on a quiet afternoon. Off to the side, in a small clearing, a wild deer stands grazing. As you approach, you remain on the dirt path, your stride steady and your eyes cast downward. The deer raises its head, its ears pivot toward you, its body tensing. But as you keep moving along the path, maintaining your distance and direction, the deer does not run. It watches you, alert but stationary. Now, imagine a small change. You stop walking, you turn your torso, you look directly at the deer, lock eyes, and take a single step off the path toward it. In a fraction of a second, the deer explodes into motion, flashing its white tail as it bounds into the thicket. What just happened? You were the same physical human being the entire time. Your smell was the same, your size was the same, and your presence was already known. Yet, in an instant, the deer's calculation shifted from cautious tolerance to immediate life-or-death flight. This simple encounter reveals a profound secret about the animal kingdom. Wild animals do not merely react to what we are. They are constantly running an active risk assessment, a real-time danger calculation that determines whether the specific human in front of them, in that exact moment, represents a lethal threat. But what exactly makes an animal decide that a human is dangerous? As we decode this animal perspective, we uncover a world of fear, intelligence, and survival that challenges everything we thought we knew about our relationship with nature. To understand how deeply this fear of humans is written into the natural world, we must travel to the South African savanna of Greater Kruger National Park. For generations, we have regarded the lion as the king of beasts, the ultimate symbol of terrestrial terror. But in 2023, a team of researchers led by Professor Liana Zanet of Western University in Canada set out to test a startling hypothesis, that the sound of ordinary human beings is actually far more terrifying to wild animals than any non-human apex predator. The researchers set up automated speaker and camera systems at various water holes throughout the park. Through hidden speakers, the team played a variety of sounds at a calm, conversational volume of 60 decibels. They played the growls of lions, the sounds of barking dogs and gunshots, and the recording of ordinary men and women speaking calmly in local languages. The results, published in Current Biology, shattered the traditional hierarchy of fear. Across 19 different mammalian species representing both herbivores and carnivores, the reaction to human voices was overwhelmingly more severe. Wild animals were twice as likely to flee and abandon the water holes 40% faster when they heard human voices compared to the sounds of growling lions. A staggering 95% of the observed species, including giraffes, leopards, hyenas, zebras, kudu, warthogs, and impalas, ran more or left the water holes faster in response to humans than to lions. Even massive elephants and rhinoceroses, animals virtually immune to lion attacks, abandoned the water holes significantly faster upon hearing the calm, conversational voices of humans. The animals were not reacting to loud screams or active hunting sounds, they were fleeing from the simple, quiet sound of human conversation. It suggests that to the vast majority of savanna mammals, the presence of a human represents a danger that completely eclipses the most feared carnivore in the wild. Why would a calm human voice strike more terror into a wild animal than the snarl of a lion? To answer this, we must look at the unique ecological footprint of humanity. In a global analysis published in Science, researcher Dr. Chris Darrimont and his colleagues described humans as a highly unusual, ultra-lethal super predator. Standard predators typically target the young, the old, or the sick, individuals that are easier to catch and represent less risk. Humans, however, do the opposite. Guided by technology, weapons, and cultural preferences, we hunt and kill adult, breeding-age animals at rates up to 9 times higher than non-human predators. But wild animals do not need to understand our rifles, vehicles, or hunting laws to fear us. Instead, they learn a simple, powerful association. Human presence has historically predicted a high likelihood of danger and death. Our predation is uniquely devastating because of how we operate. We kill from distances no claw can reach using tools and cooperative tracking. We domesticate other predators like hunting dogs to assist us. And we travel in fast-moving metal vehicles. Over thousands of years of evolutionary history and through rapid individual learning, animals have associated the sights, smells, and sounds of humans with this unparalleled lethality. We have become a universal symbol of danger, a force of nature so destructive that the mere echo of our voices is enough to clear a water hole. But how does a wild animal translate this general fear of the human species into a real-time decision? How does a bird in a tree or a squirrel on a branch decide whether to fly away or stay put? To study this, biologists use a highly standardized measurement called flight initiation distance, or FID. Flight initiation distance is the exact distance at which an animal begins to flee from an approaching threat. When an animal spots a human, it does not immediately run. Doing so would waste valuable energy and take time away from feeding. Instead, the animal enters a state of active monitoring, constantly updating its risk prediction based on a series of subtle behavioral cues. First, the animal assesses your trajectory. Researchers have found that animals are highly sensitive to whether an approach is direct or indirect. If you walk past an animal on a tangent, keeping your body oriented away from it, the animal perceives a lower risk. It interprets you as background noise. But if you turn your torso, align your path directly toward the animal, and begin an active, direct approach, the perceived risk skyrockets. To the animal, those cues can resemble an increasingly targeted approach and increase perceived risk. Second, they monitor your gaze. Many species are acutely aware of where a human is looking. A direct, sustained stare is a powerful cue. In the animal kingdom, only a hunter locks its eyes onto its target before striking. Finally, the animal calculates its distance to refuge, its speed of approach, and whether it has experienced prior disturbances. The animal tolerates your presence only until you cross that invisible line, the flight initiation distance, at which point the risk of staying outweighs the energy cost of running. If this danger calculation were simple, animals would treat every human exactly the same way, as a lethal threat. But some highly intelligent animals can classify human danger into specific categories, recognizing that not all humans pose the same level of risk. A spectacular demonstration of this cognitive mapping was discovered in Amboseli National Park, Kenya. A research team led by Dr. Karen McComb of the University of Sussex studied how wild African elephants responded to the voices of different human groups living in their environment. In Amboseli, elephants live alongside two major human communities, the Maasai and the Kamba. The Maasai are pastoralists whose lifestyle brings them into frequent conflict with elephants over water holes, occasionally spearing them. The Kamba, on the other hand, are agriculturalists who rarely conflict with elephants and present a much lower threat. The researchers recorded Maasai and Kamba, men, women, and children, speaking the same phrase in their respective languages. When played back to the wild elephant herds, the response was remarkably sophisticated. Upon hearing Maasai men, the elephants immediately exhibited defensive behaviors, bunching into tight circles, raising their trunks to smell, and retreating. But when they heard Kamba men, their reaction was significantly muted. Even more incredibly, the elephants distinguished gender and age. Played the voices of Maasai women or young boys, they did not show defensive panic. They recognized that only adult Maasai males represented an active threat. This research, published in the Proceedings of the National Academy of Sciences, proved that for some species, human is not a single risk category. The elephants extracted acoustic information, mapped it against historical knowledge, and chose a defensive strategy tailored to the exact threat that group represented. While elephants can classify human groups, other species can associate danger with an individual human face. To see this, we look to the work of Professor John Marsluff and his team at the University of Washington. In 2008, Marsluff designed an experiment to test whether wild American crows could identify and remember individual human faces that had threatened them. Researchers wore a highly distinctive, realistic caveman mask while trapping, banding, and releasing wild crows on campus. As a control, another researcher wore a neutral smiling mask representing the politician Dick Cheney, simply walking through campus without disturbing any birds. When the trapping was over, researchers walked campus wearing the different masks. Crows immediately launched into a harsh chorus of scolding caws, diving and mobbing the caveman mask. The neutral Cheney mask was ignored entirely. The crows did not forget. Years passed, and they continued to mob the caveman mask, even when the wearer walked silently without looking at them. Even more astonishingly, the behavior spread. Crows that had never been trapped, birds miles away during the original experiment, began scolding the caveman mask too. They had watched their flock mates mob the face and learned through social observation that this specific face was dangerous. Younger generations, born years after the trapping event, also acquired the defensive behavior from their parents. Over a decade later, the scolding rate against the caveman mask remained incredibly high. This study proved crows possess a highly refined, face-specific danger mapping system. They do not just fear humans generally, generally, they associate lethal risk with a specific human face, store that memory for over a decade, and transmit that dangerous profile culturally to their offspring through social learning. The ability of animals like crows and elephants to navigate human danger creates a fascinating puzzle. If humans are indeed a terrifying super predator whose calmest voice is empty water holes, why does a city squirrel let you walk 3 feet past it without flinching? This is the great contradiction of the human-dominated world. And the answer lies in a cognitive process called habituation. Habituation is the gradual reduction of an animal's fear response after repeated exposure to a stimulus that does not result in a negative consequence. In urban spaces, wild animals are exposed to thousands of humans every day. If a squirrel ran from every pedestrian, it would starve to death from constant energy expenditure. To survive in cities, animals must recalculate their flight initiation distance. They learn to reclassify humans from an active, looming threat into predictable background noise. They observe our patterns. If humans constantly walk along concrete paths without stepping onto the grass, the animals learn that the path is a safe corridor of indifference. They can feed just inches from the walkway, tensed but still, because our predictable behavior no longer predicts danger. But habituation does not mean the animal trusts humans. It has simply adjusted its risk prediction to fit the local context. If you step off that paved path, turn your body, or look directly at that squirrel, its flight initiation distance instantly resets. The context changes, the background noise becomes a targeted approach, and the animal flees. The calculation is further altered when humans provide food. While this resource availability can reduce flight distances, it also creates high-risk situations where animals must balance the reward of a meal with the extreme danger of approaching a super predator. We might assume that this deep fear of humans is confined to prey species. Surely we think an animal large and powerful enough to easily kill a human does not consider us dangerous. But modern ecology has revealed that even the world's most formidable carnivores are profoundly terrified of us, and that our mere presence shapes their entire lives. In the Santa Cruz Mountains of California, researcher Dr. Justin Sarasi and his colleagues studied how pumas, the powerful mountain lions of North America, responded to human presence. The team set up speaker systems in known puma habitats. When a puma approached a fresh kill to feed, the speakers would play either the control sound of frogs or the calm, quiet recording of human voices reading books. Upon hearing the calm human voices, pumas fled from their kills in 97% of the trials. They abandoned their food, reducing their feeding time by 42%. To make up for this lost food, the pumas were forced to kill more deer, shifting their hunting dynamics across the entire ecosystem. Similar studies on British badgers showed that these aggressive carnivores suppressed their foraging activity far more when hearing human voices than when hearing the sounds of bears, wolves, or domestic dogs. Ecologists refer to this as the landscape of fear. The expectation of human danger acts as an invisible barrier, compressing carnivores into smaller, more remote habitats. A human does not need to fire a gun or even be physically present to disrupt a food chain. The simple echo of our conversation is enough to send an apex predator running, creating a cascade of behavioral changes that ripples all the way down to the plants and soil. If humans represent such a powerful universal cue of danger, why is it that our pets do not spend their lives in a state of constant terror? Why do domestic dogs and cats sleep peacefully in our homes? The answer is found in the unique biological history of domestication and individual socialization. Over thousands of years, domestic animals have undergone genetic changes that have fundamentally altered their threat assessment systems. Domestication selects for reduced fear and increased social tolerance toward humans. This genetic foundation is reinforced by early life socialization. A puppy or kitten raised around humans during critical development windows learns to classify humans not as potential predators, but as familiar, predictable caregivers. Through daily positive interactions, they build deep social attachments, learning to decode our specific moods and navigate their domestic world safely. When we return to that quiet forest clearing where we began, we can finally understand what happened in the mind of that wild deer. The deer did not suddenly realize you were human when you turned and stepped off the path. It had been monitoring your smell, your sound, and your movement from the moment you entered the woods. It had already cataloged your presence. What changed was your pattern. As long as you maintained a steady, linear stride along the dirt path, you represented a predictable, non-threatening element of the environment. But the moment you stopped, turned your body, locked your eyes onto its face, and stepped toward it, you broke the pattern of indifference. You exhibited the precise cues of a targeted predator approach. Wild animals do not possess a complex linguistic concept of humanity. They do do not think of us in the abstract, nor do they ponder our careers, our morality, or our place on Earth. Instead, they are master pattern readers. They read the direction of our eyes, the trajectory of our footsteps, the history of our voice in their savanna, and the memory of our faces in their flocks. When a wild animal looks at you, it is not trying to understand what you are. It is trying to predict what you are about to do next. And in a world dominated by the most lethal super predator the planet has ever known, that split-second prediction is the most important calculation they will ever make.